Welcome everybody to Algebra 2, Section 3.6. Today we're going to be talking about end behavior, increasing and decreasing intervals, as well as parent functions. So we're first going to talk about increasing and decreasing intervals. And from what this is saying, it's that moving from left to right, a function could increase, decrease, or remain constant on certain intervals. Now these intervals we're talking about are the x values, left to right, whereas the increasing and decreasing aspect, we're talking about the y values. Are the y values going up or down? So, for example, to the right here, this graph, from here to here, it's going up for the y values. From left to right, it's going constant. It's not going up or down. And then from this point on, it goes down. And so increasing would be this interval between this and this. So that's negative infinity, comma 1, or excuse me, comma negative 1. And so that would say between negative infinity and negative 1, it is increasing. So that would be a parentheses. It's going up, 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 up for the y values. Now notice, even though negative 1 is a filled in circle, it's not a bracket here, it's a parenthesis. And the reason why is that it's not increasing at this point. At that point, we have a specified a y value of 3. And it's not going up at that point, just like it's not going down at that point either. It's just that number of the y value of 3. However, between this point and the negative infinity, it is increasing from left to right. So it's a parenthesis there. And we'll notice today that anytime we do an increasing or decreasing interval, we will have parentheses, no matter what, no brackets for increasing and decreasing intervals. Because it doesn't increase or decrease at any specific point. It is decreasing over an interval of points. Constant is constant from here to here from left to right, so those are the x values of negative 1 to positive 4. And then it's decreasing from positive 4 forever to the right, so that's 4 comma infinity. Now let's go and apply this here. So we have these different graphs, and we're going to say when do these increase or decrease on the intervals for the x values. For the intervals, what are the y values doing as far as increasing or decreasing? So from left to right, it is increasing the whole way through. From negative infinity to positive infinity, it's increasing. Now, if it's increasing the whole time, then what are we going to put for decreasing intervals? Since there are none, it's never decreasing from left to right here, and so there are none. So you can put none, you can put a dash, you can put NA, really anything to get across the idea that it is decreasing, never. So undefined would not work here though, because undefined is specifically for when we try and divide by 0, and that breaks math. Number 2 here, there's nowhere where it's increasing this time. It's never going up and down, never going up, from left to right. From left to right, it's only going down. And so the decreasing interval here is negative infinity to infinity. Number 3 here, the increasing interval is from here over to this point, to the vertex of this absolute value function. And that'd be from negative infinity, comma 3. Once again, both with parentheses, even though 3 is not an open circle, we're not concerned about the open and closed circles for intervals. We're only concerned about whether or not it increases or decreases, and it can never increase or decrease at a specific point. Only between points. And the decreasing intervals is from 3 to the end. So that's 3 comma infinity. Number 4 here, from left to right, it starts out with decreasing first. And so it decreases from negative infinity until our vertex of negative 1. And it increases from the vertex of negative 1 on to infinity. So from here it goes up for the y values. Number 5 with the parabola, it'll be the same thing here. We have our vertex right here at the x value of 2. And then from left to right, it is decreasing first and then increasing after the vertex. And so here it'll be the decreasing interval of negative infinity, comma 2. And the increasing interval after that of 2 comma infinity. But at the x value of 2, it's not increasing nor decreasing. It is just the y value of negative 5. Number 6 here, from left to right, it starts off increasing from negative infinity until our vertex, which has an x value here of negative 5. And then it's decreasing after the vertex from negative 5 onto infinity to the right. Now we're going to talk about end behavior. So end behavior, similarly, you're going to be talking about what are the y values doing as we're going left and right, or as we're talking about specific x values. So as x moves toward positive infinity and negative infinity, positive infinity means forever right, negative infinity means forever left for the x-axis. End behavior is saying what's happening to the ends of our graph. What's happening to the y values, aka the value of f of x, which are the y values. So on this graph on the right, as x approaches, I don't know why it just glitched out on me there, but that's fine. As x approaches, that's what the arrow means, infinity. X can never actually reach infinity, but as it gets closer to infinity and continues increasing, what are the f of x or the y values doing? So as we continue to go to the right of this graph, what are the y values doing as we go to the right? Well, as we go to the right, they're going down forever. And down forever means they're going to negative infinity. Whereas we're saying as x goes to negative infinity, we're saying goes forever left. As we go continue left on this graph, the y values are going up. So as we continue to go further and further left, the y values continue to increase. Eventually, the idea is they would get to infinity, even though it's a concept. Once again, that's why I said the idea is. So as x goes forever to the right, to positive infinity, the y values go forever down to negative infinity. And the second one says as x goes forever left to negative infinity, the y values go forever up to positive infinity. So we're talking about what are these arrows doing? What are the ends of the graph doing? That's what we mean by end behavior. And similarly to the increasing and decreasing intervals, we're saying, okay, with respect to what the x values are doing, what is y doing? So here we're going to describe end behavior. Each of these are listed as x going to positive infinity first, and the x going to negative infinity second, and that's the case for everything on this page, or excuse me, all the examples on this page. I didn't mean to put that link in there. So as x goes forever to positive infinity here, the y values are going down forever, so that would be negative infinity. They decrease without bound. They decrease without stopping. And as x goes forever left, the y values are going forever up, and so that'd be to positive infinity here. On number 8, as we go forever right to positive infinity, we also go forever up, which is also positive infinity, but for the y values or f of x. Whereas when x goes to negative infinity forever left, the y values also go to negative infinity forever down. Number 9 here. As x goes to positive infinity, as we go forever right, the y values are going up forever, so that's positive infinity. As we look this time, as x goes to negative infinity, the y values are again going up. So the y values are again going to positive infinity. In this case, both sides, whether we're going to the left or to the right, the y values are increasing forever to positive infinity. Number 10 here, we have the exact opposite. Whether we go left or right, the y values are going down regardless, meaning our end behavior for both directions, positive infinity and negative infinity for x values, is negative infinity for our y values. It's going down forever regardless of whether we're going left or right forever. Number 11 here, we have a parabola for a quadratic function. So as x goes forever to positive infinity, it's kind of glitching out there, we end up having the y values go to negative infinity. And as x goes forever to negative infinity, the y values go down forever as well, which is negative infinity. On number 12 here, another parabola. As x goes forever right to positive infinity, the y values go forever up to positive infinity. And as x goes forever to negative infinity forever left, the y values go up forever as well. And so that's positive infinity. So we notice here on the absolute value functions, both ends are either both positive infinity or both negative infinity, depending on our parabola or absolute value functions, but regardless, they're both going the same way for as far as both going up or both going down forever. Whereas with our linear functions, one is going to negative infinity and one is going to positive infinity, but which one is which depends on the specific graph. And that'll be a consistent thing that we notice, that linear functions will always have the ends going to different directions, positive and negative infinity, whereas absolute value and quadratics will always have the ends go to the same place, either both to going to positive infinity or both going to negative infinity. So So now we're going to talk about some parent functions. And we've talked about parent functions throughout this unit, over the course of the unit. So this is not anything new we're going to do right now. We're going to just do a review, because the new part here where it says like cubic and on the next page it goes on, we're just going to skip over actually, because we'll be covering those individually throughout the year, and I don't want to bombard you with a massive list of parent functions now and confuse you. So a reminder that a parent function is the simplest function of a function family. And a family of graphs displays similar characteristics. So all the linear functions with all of their changes and transformations are all still part of the function family for linear functions. Same thing with absolute value and quadratic, each being their own function family and having their own parent function. So here we're going to talk about the parent function and some characteristics of the parent function. That these a lot of these end up transforming or changing due to different transformations we apply to them. So the parent functions for linear equations with f of x equals x. And this just looks like a straight line going diagonally with a slope of 1 with the going through the origin 0, 0. The domain for the the domain for the linear function is negative infinity to positive infinity, which we also know to be all real numbers. And the range is the same. It goes forever left, forever right as well, which once again we know to be all real numbers. Then the x-intercept, where does it cross the x-axis? It crosses the x-axis right here at 0, 0, which is actually the same place it crosses the y-axis, also at 0, 0. It crosses both there because the origin is where those two axes meet. The end behavior as x goes to, we listed it earlier as positive infinity first, so I'm going to go ahead and be consistent there and list it as positive infinity first. The y values, or fx values, also go to positive infinity. So we go forever right, we go forever up. And as we go forever left to negative infinity, we go forever down to negative infinity as well. The increasing intervals, this is increasing the whole time from left to right, always talking from left to right. So that's negative infinity to infinity, whereas the decreasing intervals don't exist. There are none on the parent function of a linear function. Moving on to absolute value. Absolute value of the parent function is f of x equals the absolute value of x. The graph starts in the origin again, and it has a slope of 1 heading each direction. Up and left, up and right. The domain here is, once again, negative infinity to positive infinity, which we could also write as all real numbers. However, the range does change. The range, in this case, is 0, infinity, the lowest point being 0 on the parent function, but it's a closed circle, so it's a bracket, comma infinity forever up. Or you could write y is greater than or equal to 0. The x-intercept and y-intercept are both again at the origin where the axes meet, and that's where it crosses both the x-axis and the y-axis. And different transformations will change that, but for the parent function that's the case. And as x goes once again to positive infinity, forever right, we go forever up. So positive infinity. And as x goes forever left to negative infinity, y goes forever up again to positive infinity. Oop, there should be a negative infinity on that second x. The increasing intervals, it's increasing from the origin or the vertex on forever to infinity. So it's 0, infinity, with 0 being a parentheses though, because increasing and decreasing intervals are always parentheses because you can't increase or decrease at a specific point. And the decreasing intervals is forever left to the origin there, which would be negative infinity. My pencil glitched out. Negative infinity, 0. And then the quadratic was our other one that we had. The quadratic is f of x equals x squared. My apologies, I wrote a, but x squared. Once again, it's centered at the origin, and then it increases following the formula as you plug things in and get y values out. But it goes 1, 1 and negative 1, 1, and then 2, 4 and negative 2, 4. We find that by squaring the x value. So squaring the x value of 1 gets us a y value of 1. Squaring the x value of 2 gets us a y value of 2. The domain here is again negative infinity to positive infinity, all the x values, or the all real numbers, where the range similar to absolute value is 0, comma, infinity, with 0 being a bracket. And then the range could be y equals, or y is greater than or equal to 0. That's another way to write it. The x-intercept and y-intercept are again just at the origin 0, comma 0, because that's where it crosses or meets both axes. The end behavior, as x goes forever to the right, the y values go forever up. As x goes forever to negative infinity, or to the left, y also goes up again. And so that'd be positive infinity. And the increasing intervals are from the vertex forever to the right, which is 0 to infinity. And the decreasing intervals is from the left forever to the vertex, which is negative infinity, comma 0. Once again, we're not going to cover cubic today because I don't want to confuse you at the end of this unit. I'm only instead talking about the functions that we've covered in this unit, which are linear and the new two of absolute value and quadratic. Now, to recap these, the domains for each of these are always 100% of the time all real numbers or negative infinity to infinity, whereas the range is only negative infinity to infinity or all real number for linear, but whereas absolute value and quadratic are not that way. And the x-intercept and y-intercept move around for these depending on transformations that happen. And for absolute value and quadratic, it's even possible to have two x-intercepts, such as like here across the x-axis twice. But each of these only will have ever one y-intercept, even though it can move where it is. And the end behavior can also change, but noting that for, as I mentioned earlier, absolute value and quadratic, that the y values will either both go to infinity or both go to negative infinity, whereas for linear, one will go to infinity and one will go to negative infinity, but which one is which will change. Linears are always either increasing or decreasing, but never have sections where they're doing both, whereas for absolute value and quadratics, they will have periods where they increase and decrease. It'll be half the graph each time is increasing and half the graph is decreasing. And this page as well, once again, just not covering today the parts that we're going to be covering in the future, because I don't want to confuse us right before we review and take our tests. So moving past this, we're going to do some function families review, but notice it says only for linear, absolute value, and quadratic. So a little bit more review and a little more specific review by giving specific functions. So we're going to graph each function, then identify the characteristics, saying what family it belongs to, what's the parent function of that family, and then some more specific information to that graph specifically. So as I graph this f of x equals negative 3x plus 5, it's important for me to note that this is linear. It follows a linear format of y equals mx plus b. And the parent function of that is f of x equals x, like we just talked about. I can already fill in the domain on every single one that we'll be doing today as negative infinity to infinity or the all real numbers. And I can actually already know that's my range as well here on linear functions, because the range is always negative infinity to infinity or all real numbers for linear functions. Now, as far as the rest of this goes, I'll have to actually graph it in order to see more of this. And so as I turn to graphing it, I notice that my b is 5, which is where I will begin, and the m is negative 3 or negative 3 over 1. So I go up 5 to the y-intercept of 5, and then I go downhill from left to right with my negative slope. So I'm going to go down 3, right 1, or I can go up 3, left 1, and go off the graph. And I connect these, make my points, and now I note that the end behavior is as x goes to positive infinity, y goes to negative infinity, and as x goes forever left to negative infinity, the y goes forever up to positive infinity. There is no interval on which it's increasing. There are only the decreasing interval is only the decreasing interval, which would be negative infinity, comma infinity. And I know these all say interval or intervals, but nothing for linear functions, quadratics, or absolute value will ever have multiple intervals that are increasing or multiple that are decreasing. So now we're going to talk about number 2 here. This is an absolute value function. We note that because it has absolute value bars. So it's part of the absolute value function family. And the parent function for this is f of x equals the absolute value of x. The domain, again, for all of these that we've covered are negative infinity to infinity, or all real numbers. This time we can't fill out the range ahead of time, nor can we fill out anything else past this until we graph it. We do note that the vertex is 1, negative 4, that this one's a liar, but tells us the x value. So we go 1 to the right, 4 down. I know that this is opening up because it's positive, and I know the slope is whatever number the a is, which is 1 or 1 over 1. So I'm going to increase at a rate of 1 over 1, positive to the right, negative to the left for the slopes. In this case, since it's a positive a, if it was a negative a, that would be switched around. And now I can note that my range is the lowest point of negative 4, the highest point of infinity, which is the point, but negative 4 being a bracket because it does actually reach that. The end behavior, both ends of the graph to the right and the left have the y values going to infinity forever up. The increasing intervals from our vertex forever right, which is 1, infinity. The decreasing intervals forever left to 1. So with parentheses as well, here forever left. Moving on to the next one. This one has an exponent of 2 in it, so it's quadratic. And it follows the ax squared plus bx plus c format. The parent function is f of x equals x squared. The domain, as we mentioned, is always, for everything we've covered in Unit 2, negative infinity to infinity, or all real numbers, but I can't do the rest until after we actually start graphing. So I do notice that this opens down, it's important to note, but I do need to find the axis of symmetry and then the vertex. We're not told it since it's not in vertex form. So this is x equals negative b over 2a in order to do this, which is negative of 8 over 2 times negative 1. That gives me negative 8 over negative 2, which is positive 4. So x equals 4 is my axis of symmetry, which maybe you want to do a dashed line, maybe you don't. Either way is fine. I plug that in to find my vertex, and as I find my vertex, I end up getting it to be in this table I'll make. 4, 5. I knew we needed to make more points, so I'm going to use a table to do this. And the points that I get, the x values I just increase and decrease to the next integer, and the y values I get when plugging these in would be try that again, negative 4, 1, 4, and then they mirror on the other way. And I go and graph these. Sorry, that was positive 1, negative 4, but I did negative 1. And there we have a graph. So now we can note that the range is negative infinity, the lowest it gets, going all the way up to 5 with the bracket. Or you could word it as y is less than or equal to 5. I never did the other one for the range on the absolute value, so I'm going to go back and fix that. That's y is greater than or equal to negative 4. Back on the quadratic, the end behavior for both left and right is that we're going to negative infinity. It's going down forever regardless of whether we're going left or right. And the increasing interval is from the left to the vertex, which is negative infinity, 4. And the decreasing interval is from 4 to infinity. There we go. So here we have another absolute value one. I know that because, well, it has an absolute value bar, which you could abbreviate if you want, like I just did. The parent function of this is f of x equals the absolute value of x. Domain, like we mentioned, is 100% of the time, negative infinity, infinity, or all real numbers, but we do need to graph it in order to figure out more than that. So as I seek to graph this one, I note that the vertex here is 0, 6 because it's not moving left to right at all, and it will open down with a slope of 1 over 1, both positive and negative. And I should have made my one on number 3 positive and negative, noting that I did note that it's positive one direction and negative the other. In this case, which direction is positive and negative will flip because the graph is reflected vertically. So I make my vertex. I'm going to go down and right or down and left, both going down. If it keeps going down, it might be yelling timber. The range here would be the lowest is negative infinity, the highest is 6, with 6 being a bracket. Negative infinity is a parenthesis, excuse me. Or y is less than or equal to 6. As x approaches positive infinity or forever right, the y values are going forever down. And as x goes forever left, negative infinity, the y values can also go down. Negative infinity. The increasing intervals is from negative infinity to our vertex of 0 with the x value. So negative infinity, comma 0. Decreasing is everything after that, so 0 to infinity. And on to our last page for this unit. We look at number 5 here. Number 5 has an exponent of 2, telling us right away that this is quadratic, which says the parent function of fx equals x squared. And again, it's the domain of negative infinity, comma infinity, or the all real numbers. We have to graph it in order to figure out more information than that. This is in vertex form. I love that. So the vertex here is negative 2, comma negative 7. And so I'm going to go ahead and graph that vertex. This will open up since a is positive, and we do note that it does stretch. Now I'm going to make my xy table. I'm putting numbers around the x value of my vertex. And then as I find these y values, I get the y values of 11, 1, negative 5, negative 7 we talked about, negative 5, 1, and 11. 11 goes off my graph for the y value, but that's okay. I'll just graph the other ones since I have them. And there we have the graph. Now I can continue with my range, noting that it's anything bigger than negative 7, so negative 7 to infinity. Or I could also word it as y is greater than or equal to negative 7. The end behavior, as x goes to the right or to the left, both, it's positive infinity. Y values go up forever. The increasing intervals would be from the vertex to the right. So that is negative 2, comma infinity. And the decreasing intervals is from the left to the vertex, which is negative infinity, comma negative 2. Number 6 does not have absolute value bars and does not have an exponent of 2, meaning it is linear. The linear parent function is f of x equals x. The domain is always negative infinity to infinity, like everything we've covered in this unit, all real numbers. However, this time the range is also the same, negative infinity to infinity, always for linear functions or all real numbers. But to find out more, we have to actually graph. So when I go to graph, I note that the m is 5 over 2, the b is negative 1, and that's where I begin. So I go down 1 for a y-intercept of negative 1, and then my slope is positive, so I'm going to go uphill from left to right as opposed to downhill from left to right. I'm going to rise 5, run 2, or fall 5 down and run 2 to the left. And I have my graph. This helps me know that as x goes forever to positive infinity, forever right, the y values go forever up to positive infinity. And on the opposite end, as x goes forever left to negative infinity, the y values go forever down to negative infinity. This never decreases because it only increases from left to right, negative infinity, comma infinity. Number 7 here, we see an exponent of 2, which tells us it's quadratic. The parent function is f of x equals x squared. The domain always is negative infinity, comma infinity. as you guys are probably getting tired of me hearing, or me saying, and you hearing. Now I actually need to graph this. I can note that the vertex here, since it's in vertex form, is 5, 6, noting that this is a liar, but my 5 didn't want to stay written down. And this will also flip and reflect over the x-axis, good for us to note. So it's going to open down. And as I make my table, I'm going to list the x values 2, 3, 4, 5, 6, 7, 8, 9. Noting that 9 is definitely off the graph, but that's okay. I know that 5, 6 is my vertex, so I'm going to put that in, and then I'm going to plug in these other x values to find the y values. The results of that would end up being -3, 2, 5, 6, like we already covered, 5, 2, -3, and I don't know why I went to 9. I'm just going to go ahead and erase that because I already have enough in each direction. More than enough, really, but that's okay. So I'm going to plot the 7 points. So 2, -3, 3, 2, 4, 5. I already plotted the vertex, and now I plot the way down as well on the other side. And I have my graph. So the range here would be from -infinity down forever, 6, the highest point. That is the parenthesis on that left end. You could also write that as y is less than or equal to -6. The end behavior, both to the right and the left, +infinity and -infinity for the x values. The y values are both going to -infinity down forever. Increasing, it increases from the left all the way to the vertex, which is -infinity. Oh, my circle didn't want to erase there. I would like that gone. -infinity, 5, excuse me. And then it decreases after that point to the right, so 5, infinity. And then our last one for the unit is f of x equals 1/2 times the absolute value. Hey, I said absolute value, telling us this is the absolute value function family, so I can stop reading at that point and start working on this portion. I note that since it's absolute value, the parent function is f of x equals the absolute value of x. The domain is always -infinity, infinity. Once again, with everything we've covered in this unit. And the way to write that is all real numbers, but I need to graph in order to do the rest. So I note here that the vertex is -3, 3, because this is a liar. So I'm going to go ahead and plot that point. My slope here is this 1/2, whatever a is, and it is positive, so it'll open up. So it's going to go up and right, or up and left. So I'm going to go up 1, left 2, or up 1, right 2. And that's my graph. So now I can do the range, which is the y value of 3 and anything higher, so 3, infinity, with 3 being a bracket. Or I could say y is greater than or equal to 3. As x approaches positive infinity or negative infinity, to the right forever or left forever, the y values do the same thing, as both going up forever to positive infinity. The increasing intervals would be from the vertex over to the right, so that would be from -3 to infinity. Where the decreasing ones would be from the left forever to the vertex, or -infinity, -3. And without further ado, we are now done with section 3.6, and behavior, increasing, decreasing intervals, and parent functions.